I'm just interested, by show of hands, who in the audience works with SUSE products and SAP products? So pretty much everybody. Who works, who has a HANA database at their site? And I'm curious, because this actually pertains to the discussion. Raise your hand if your HANA database size is less than 2 terabytes. Okay, a couple of you have more than 2 terabytes? More than 4 terabytes? More than 10 terabytes? Wow, you must do a lot of transactions. So what do you run? Do you run supply chain management or ECC, or do you run, what on top of HANA do you run? Do you run ECC or something? BW? Okay. Anyways, so I'm going to live without the clicker, which is fine. So I'm just curious. So I have to admit, in a previous life, I used to be a systems analyst, which includes systems administrator. And this is going to date me. And it was on another Linux version, the red one. And I used to be a DBA on Oracle and Informix databases. So I also, when I started school years ago, I worked on AIX and HPUX and worked at a small Unix vendor called Sequent Systems that was bought out by IBM in the late 90s. So there's one Sequent alumni. Anyways, so this week, after 3 years of prototyping, do any of you go to Sapphire, SAP Sapphire? So it was 2 years ago we actually did the first live demo of persistent memory technology on the HANA database. And then last year at Sapphire, Hasso Plattner, in his keynote, he said he promised last year one of the top 5 innovations that would be releasing last year, so this is 2018, last year that persistent memory would be one of the 5 that was releasing. And he talked about database restart times, also known as database load on startup, so not the operating system layer, but how long did it take for that database to reload. And he showed an instance where it ran from, it was a 6 terabyte instance, so that would probably apply to you, my friend. A 6 terabyte instance that went from 50 minutes, and this is on, I'll just say slower solid state drives. It took 50 minutes to restart the database to 4 minutes. Now, today, or I should say at this conference, I've been bumping into a couple of my old colleagues in terms of being a systems administrator, database analyst, whatever you call it. I think there's 3 roles there, but some companies you do everything. And they thought that was fabulous. If I could get an extra hour in my maintenance window that might be 3 or 4, that's going to save the company quite a bit of money because they're not running the transactions through the system. So today I'm going to talk about Intel Optane DC persistent memory. It just rolls off the tip of my tongue. It's funny when I go prep my execs to speak in public, and they've known about the product name for 9 months, and they can't even say the product name right. But in terms of systems, what I'm going to talk about, so you think of NVMe solid-state drive-based technology. So basically, we've taken that same technology and put it in a DIMM form factor. So on your server, you have another option. You still have DRAM, and now you have persistent memory that plugs into the same slot. And what it's going to give you is the ability to scale and, quite frankly, to have fewer systems. So it's pretty powerful because at the end of the day, it's not just a CapEx cost because we're going to drive down the cost of DRAM DIMMs. But it's also an operating cost because you need less systems now to run HANA. So hopefully it's a perfect opportunity for you all. Okay, so I actually sit on an engineering team. I'm the product guy in the engineering team. And when we think of persistent memory, over the years, on HANA, for instance, we've been collaborating with SAP for 10 years. And they actually came to us, Hasso came to Intel think it was about 12 years ago, and he said, well, I understand you have this issue now. You can't just make the processors faster because there's thermal issues, right? Remember that about a decade ago, right? And so that's when we started doing core technology, so just adding more mini processors on the same processor, right? And so he said, well, how can I leverage that? And so we worked closely with Hasso and his team, and even today we still have 5-7 engineers that sit in Waldorf that we co-innovate with them, and I'm the product guy that gets to communicate all the good work they're doing. And when I look at over the years, it was not just multi-core. Starting with SIMD instructions, we would add instructions for them for HANA specifically. We added AVX, AVX2, AVX 512. About 3 years ago on the Intel Xeon E7 v3 added a new feature called TSX, which coincidentally is about the same time that HANA became not just an analytical engine, but can handle transactions too. And that TSX feature actually sped up transactions by almost 600%. So that's been in the processor for years. And then the last 5 years, we've been co-innovating on persistent memory. Now, I want to be clear on persistent memory. I should get into this a little bit. There's actually 2 modes. So if someone says they support Intel's persistent memory, and they haven't done all the hard work that SAP did to write at the byte level to basically ignore the operating system and just go to the DIMMs, the new persistent memory DIMMs directly, it's a lot of work. And SAP is proud to be the first major RDBMS that supports persistent memory in what we call at direct mode. And other databases like SQL, they run with persistent memory, but they don't have the persistency. So that DIMM just acts like a larger DIMM. It loses the data. Whereas HANA, and I'll get into this in more detail, it uses the non-volatile nature of these persistent DIMMs. And so pretty powerful, and we'll go into some use cases here a little bit. Okay, so just this kind of gives you a nice history. So this week, we actually, on the right, we released Cascade Lake, which is the 2nd generation of Intel Xeon Platinum processor. And that was the first processor that will support persistent memory in production. On Tuesday, we didn't just release the new Xeon product and the new persistent memory product, but we released a dual port instantiation of the P4800X, the high-end NVMe solid-state drives. We released new NICs and new silicon for the FPGA. So beyond HANA, we also do enabling on IoT, and we've continued to do work in AI machine learning. And just one fun fact on machine learning, the HANA's PAL libraries work very well on Xeon. So if you're trying to get sold a bill of goods that someone says you need an NVIDIA GPU in there, the answer is you probably don't. There will be scenarios that you will, though. So SAP, I'm going to be honest, like I said, they've worked on it for 5 years. They actually released the first version to support persistent memory even before we released our product. So I have to admit, I made Hasso, I don't know if I want to say a liar, because we were supposed to release it like in Q4. It was released on Tuesday, right, the new product. But their code was froze back in May, and it supported persistent memory. And what you'll see in 2.4 is there'll be some hardening. So we've done a lot of proof of concepts with real-life customers with the new hardware and the new version of HANA. And there's going to be new features around the extension nodes, which is a feature that it's not necessarily a replacement of dynamic tiering, but it's another way to think of your heat map differently. So look to that if you do. So I think what's powerful about this new processor, if we kind of do the stepping stone, and probably the key numbers here is how much for HANA. Now, to be clear, this is how much HANA supports per processor. And the original goal is we're hoping to release persistent memory on the first version. Well, it required quite a bit more work because we had to change our memory controller. There was a lot of firmware and BIOS work, and then we had to enable the ecosystem. So what we actually did in the first generation is we took half of the DIMM slots away. And so, yeah, you know what I'm talking about. So a lot of people, I'm going to be honest, they just stayed on the E7 V4. Well, the E7 V4 to the 8180 and now the 8280, if you go to SAP HANA benchmarks page, there's about a 50 to 60% performance boost, okay? But people, I'm going to be honest, if I were you and you took away half of my DIMM slots, I would have stayed on that too. So not only do we have this new persistent memory technology, but you can look forward to 50 to 60% performance gain on the new processor, okay? And so instead of having 3 terabytes that was available in the E7 V4, we now have 4.5 terabytes per socket. And the other thing that's powerful with that is HANA supports all of it. So on a 4-socket configuration, if you do the math, that means you can get 18 terabytes in HANA. And the other thing that they've done that's even more powerful is there's always been this kind of scenario for scale out for analytics. On the prior generation, it was only 0.75 per terabytes was the recommendation. Now you can go all the way up to 4.5. So a 6x improvement for analytics and 3 times for transactions. So pretty powerful. You're going to have capacity. You can already start thinking in your heads, well, I could probably consolidate some systems, maybe use the MDC to host multiple HANA instances on one system, right? So we'll talk about that in a little bit. So just a reminder, we continue to be the best TCO versus power. We have about 53%. Everybody's familiar with the rich ecosystem, and scale opportunities are going to increase. Obviously, if you want to run a hybrid or multi-cloud scenario, lots of players in the ecosystem today. If you're interested in persistent memory in the cloud, Google Cloud or GCP is the only one that's available today. Others will be announcing in the Sapphire timeframe. The other thing to realize is if you want to use persistent memory, for those who've been in the SAP and SUSE ecosystem for a while, a couple of years ago, pretty much 80% of you use certified appliances. Well, with my friends, I keep on doing that, but with my friends from SAP, they've told me that now that model has kind of been flipped. The majority of their customers are using TDI. You can do self-cert there. And if you want to use persistent memory, that's the only way you can use persistent memory is with TDI. And obviously I'll just show you a picture of the Quick Sizer tool to remind you. And then you guys here are probably going to be most interested in this. Well, so if I want to do persistent memory, what version of SUSE Enterprise Linux do I need to have? 12.4 or SUSE Enterprise Linux 15. So what it then appears as is a journal file system. And I have to admit, and back in my day, I remember using the mount command. So it just appears as a file system in etc pmem. Okay? Though it looks and smells and acts like DRAM outside of the fact that your operating system cannot be run on it. So what that means when you're populating DIMMs is you have to have one DRAM DIMM, a persistent memory DIMM, one DRAM DIMM, persistent memory. So you can kind of go down the line as you populate your slots. It is a one-to-one. It doesn't necessarily have to be in terms of sizes. Sizes, depending on what the Quick Sizer tool spits out, it could be a 4-to-1 size. So if you buy a 0.5 terabyte DIMM, persistent memory DIMM or module, you could couple that with 128. So you can do the math. Quickly, that can get to 4.5 terabytes. Also announced this week is that the DRAM vendors are going to start supplying a 1/4 terabyte DRAM DIMMs, okay? So if you do the math, you can understand it. Well, if you have 12 slots, that's how 256 with 512, that gets you the 4.5 terabytes per socket. So on our launch, these are just kind of some of the, as a reminder, it wasn't just this new persistent memory. It was Xeon Platinum that released on the left and right, but we also did things with new products with silicon photonics, new Ethernet adapters, new OmniPath fabric. So if you go to the Intel press room, you can watch whatever webinar might pertain to your company. So now let's do the deep dive on persistent memory. Like I said, we took the NVMe solid-state drive technology and put it in a DIMM form factor. It allows much larger capacities, and now you can buy DIMM sizes of 128 quarter terabyte and a half terabyte sizes. And this kind of gives you kind of in terms of your heat map where things fit in. You know, obviously the top is still DRAM, but I want to be clear, persistent memory is in the same performance envelope as DRAM. Okay, you're not going to plug it in and see a significant difference. And on writes, it's essentially identical. Or I should say on reads, it's identical. Writes, it's marginally, meaning 3 to 5%, which is probably going to be hard as a system administrator to notice the difference. But it's marginally slower. So it's in the same performance envelope, and you probably won't notice as an end user any difference. So, but basically, we've taken the solid-state drive technology and now put it in a DIMM form factor. Okay, so let's start thinking about your heat map. So when you have your in-memory database, today, or I should say last week, you would put that in DRAM. And then for your warm data, obviously your methodology for your company, this is the Intel spin on it, right? You could put your warm data in NVMe solid-state drives, and then your big data, IoT data, in the blue would be lower end. It could even be spinny drives, or in Intel speak, I'd recommend NAND-based solid-state drives. So now that we have this, we've increased the capacity to 4.5 terabytes, we have kind of this new middle tier where you could actually pull some of your warm data into hot data. And that's where you can put persistent memory. So pretty powerful because you can look at it at two ways. You can either do methodology where you consolidate multiple instances, or you still have just one system per instance, as an example. But then you change the way you do like monthlies or quarterlies, where you store that data. That's going to change. Okay, and as a reminder, like I said earlier, for transactions versus the last generation, we're 3x the capacity, and for analytics, up to 6x. And you need HANA 2.3, or as SAP announced at our launch, 2.4 will be coming out this month. So historically, if you look at the light blue, that's what the system supported. So on the first generation of Intel Xeon Platinum processor, which is this right here, that was the first time that SAP HANA caught up. And now today, as you can see, it's triple that for transactions and 6x. So the full amount that's supported by the system is supported by HANA today.
Question.
Yes?
So it says HANA appliance, but you said earlier TDI only.
Yeah, TDI only.
Okay, so you won't get 4.5.
No, you will get 4.5 with TDI.
No, in TDI, yes, but not in the appliance.
Not in the certified appliance, you're right. That's correct. So I need to go back and fix that. So good catch. You got your picture? Okay, I'll wait for you. Okay, so then you think about it, well, you have this new capacity, what can you do with it? Since you can consider, so when I talk to people that have 4, 6, 8 terabytes of HANA, what do they tell me? What is the most expensive part of that hardware? I'm not talking the SAP or everybody the software licenses. What's the most expensive part of that hardware? Is it it's memory, right? What I've constantly hear from people is, Samsung is gouging me, right? And I've heard that like on a 4 to 6 terabyte instance, it's 60% of the hardware cost is just the DIMMs. It's not the sheet metal, it's not the proprietary OEM technology, it's not the processor, it's the DIMMs. So our intention is to help drive, as we gain traction in the ecosystem, help drive down the cost of DRAM by coming in with similar performant Intel Optane DC persistent memory, but coming at a lower price point. And so we're going to consistently adjust prices to make sure that we're lower. So that's a commitment. The other thing to think about, now that you have more capacity, obviously you could do consolidation of multiple instances. So technically you need less systems. And if you need less systems, then you have less, your operating cost goes down, right? And I also like to think about business continuity. When I think about business continuity, I think about it's not just the data load on startup of your HANA database. It's what can you do for backup and even disaster recovery. Now, some of our early POC customers, what I've seen, what they're doing is, since they know Google has this huge pipe, is they still have some on-prem, but they're replicating to the Google Cloud as their disaster recovery area. Now, you can do that obviously within your company in a disparate geography, but the larger capacity allows you to do that. And also what I'm seeing as early adopters is they're still going to have some systems with DRAM only, but they're going to replicate to a persistent memory area because it has way more capacity, okay? And we talked about capacity quite a bit, so let's move on. So let's look at a scenario. So this is actually a proof of concept that we'll have written up in time for the Sapphire timeframe. That's Intel IT. So Intel IT, today we have about 21 servers running ECC, SCM, running HANA, and it runs Intel supply chain management. Now, when you think of Intel supply chain management, obviously our number one product is processors, but we ship about 1 billion products a year to over 20,000 customers. And we have several, we don't have a 6 terabyte instance, but I think our biggest instance of HANA is like 3 terabytes, okay? So what we're looking at is now that we have an immense amount more capacity, and I have to admit, we're one of the early adopters, so we have systems that are E7, V2, and V3 that now we're going to upgrade to the new second generation of Intel Xeon Platinum, but it gives us a consolidation opportunity. So these numbers in terms of cost per terabyte, this is data from the end of Q1, but at the end of the day, our old systems, it cost about $67,000 per terabyte. Now, for the memory capacity, it's about down to $42,000. So it goes back to my point that we're driving down costs. So this is another data point. It's not necessarily Intel IT, but it's another way to look at it. So this is a 1.3 terabyte instance that the data time on reload went from 20 minutes to 90 seconds. And it's because it's near instantaneously. And another, in this scenario, it went from 67,000 from buying a current system to a new system with 38,000. So this is DRAM only and DRAM with persistent memory. So who likes to talk to the CIO or the operations guy on your team that's determining what hardware you can buy? Isn't that a fun discussion? Well, when I worked at Sequent, I worked in IT, and I sat next to the CIO, and I didn't like talking. He was actually a friend of mine. He'd always give me like basketball tickets. But I had lunch with him regularly, but I didn't like to talk to him about pricing discussions because it was never fun. Because he was always trying to find the best way to squeeze the most out of what we had, right? And this just real quickly gives kind of some of the numbers. Okay, let's talk business continuity. So how does persistent memory work with HANA? This is kind of I call it the layered cake that fell over, okay? So today you're still gonna, with the new Intel Xeon Platinum, you're still gonna need some DRAM to run your operating system, to store the temp files, to do it's the temporary write. So if you're writing a transaction that microsecond, you still need some DRAM, okay? But all of your main memory, or the bulk of, or I should say 95% of the HANA database, I see it as the column or data store, that's going to be in persistent memory. So if you think about it, if all of your column or data store in this column or database, right, is in persistent memory, then database time on reload is going to be near instantaneous, right? If it's 6 terabytes, obviously you know it's not going to be instantaneous, but it's going to go from about an hour to a couple minutes, right? So if you guys decide to go the route of persistent memory, just think of your Saturday 5 p.m. shutdown window. You just got an hour back on your Saturday. Now, what I'd actually recommend is the first time you do it, don't tell the communications or the ops director. Tell him that you still need 4 hours for your window, right? And then he's going to be dazzled by how awesome you are that you reduced it by an hour. You probably won't get it back next time, but if you got done an hour, I remember doing a lot of maintenance at Saturday. We had picked Saturday at 8 p.m. and it was always the best time in the day on Saturday to do maintenance. But think about it. Now you've got an hour back in your schedule. Maybe you could do more maintenance. Maybe you could just shorten the window, right? And obviously you're still going to have some storage needs, but persistent memory, when you're thinking about your hierarchy of storage, that could potentially, if it's going to be your disaster recovery, then maybe you need less storage, right? If it's always there, maybe you need less backup to the backup systems of where the data is stored, right? So it's pretty powerful. It's not just the data load on restart time, but it'll give you an opportunity to re-architect even your storage paradigm. And this is the proof point that Hasso, that I already mentioned, he talked about 6 terabyte instance, went from 50 to 4 minutes. So when I think of persistent memory, I also think of replication opportunities. So on the left, we have several nodes. This could be ECC, this could be SCM, test dev, and this is probably where you're going to bring persistent memory into your ecosystem, okay? Because you're not going to just move everything over, because A, you probably don't have budget to buy all new systems today, and B, it's going to take time, right? So I think early on what we're going to see is a lot of people use persistent memory in a replication scenario where they use it as their backup node, potentially their disaster recovery node. And it gives you an opportunity to bring it in, make sure it's rock solid, and then plan further to put it in your production nodes, right? Okay, so increased memory capacity. Who uses dynamic tiering today? A lot of work, right? Who uses warm data, what is it? Sybase IQ? Now, what's the main limitation of Sybase IQ? What? Not falling over. One of the biggest complaints, I hear is it doesn't run as good as HANA. I don't have all the analytic libraries that I have in HANA. Well, in SAP HANA 2.3, they actually, not that dynamic tiering is going away, don't get me wrong, but they added a new feature called extension nodes that allows you to migrate off of Sybase. Okay, so you can, I'm hearing a loud roar of applause there. And what that does is, well, good, I don't have to administer 2 databases, thank goodness. I can just have another HANA instance in this extension node. Well, since, like I said, we work with them, they didn't just enable persistent memory, they actually created this feature for Intel IT. So now you can use it. And what it does is you have now an extra HANA instance, but they actually allow you to support. So for your main hot node, your primary node, you can at most with the QuickSizer support a 4-to-1 ratio, meaning the persistent memory modules are 4 times the DRAM modules. Well, in this scenario, for your warm data, you can do 8-to-1. So if you know that the less expensive DIMMs are not 128 gigabytes, you can buy 64 with like 512 Intel DIMMs, right? So that's pretty powerful, allows you to scale. And look in 2.4, I probably shouldn't say this, I'll probably lose my life for saying this. But there's going to be some hardening, and there's going to be some enhancements of extension nodes in 2.4. So when that comes out this month. Okay, so let's just look at some, well, to you guys, we'll just look at, I'm not going to call them DIMM populations, but they're just some typical scenarios. So if today for transactions on your existing first generation Xeon Platinum or the E7 V4 Xeon processor, the biggest you can go is 3 terabytes on the left with 128 gig DIMMs. Well, let's be honest, we all know that the biggest DIMMs are like 4 times as much as the next size down, right?
No more.
No more? Well, hopefully not, but I'm going to say 128 gig DIMMs are going to go down now that 256 are out. So a lot of people are, instead of doing the full 4.5 terabytes, they'll probably consider doing 7.6 on that one. So this is 2-socket, okay? 2-socket on the right. So instead of the last one doing 1.5 per socket, now you can jump to 7.6 terabytes per socket. That's probably going to be a little more economical. Another way to look at it on a 4-socket scenario, so instead of having only 6 terabytes support for your database, now you can go to 15.3. But once again, these are still 128 gig DRAM. And what also came out this week or was announced was 256 gig DRAM. So you probably want to know, what's the maximum? The maximum is 18.4 terabytes on a 4-socket. And then you probably want to know, well, what about an 8-socket system? Well, HANA has this kind of, on one system, they're only comfortable committing to 24 terabytes. So in an 8-socket system, you can get another 6 terabytes, okay? Even though that 8-socket system will support 36 terabytes of memory. So you'll need to decide what you do in terms of capacity planning. Okay, let's do a couple of use cases. So this is a quote from our data center officer, Aziz Safa. And like I said, they've been using persistent memory, and you'll see in the Sapphire timeframe we'll have more white papers and details that talk about what we've done at Intel IT on persistent memory that you can use as a base model of what you might consider in your own ecosystem, in your own internal data center and or hybrid or multi-cloud scenarios. Anyway, so what it kind of boils down to is what we're seeing in Intel IT, it's not just more capacity, the ability to consolidate. What we're seeing, now realize we have lots of E7 V3 in-house, okay? So if we have E7 V3 in-house, those processors, first of all, are about half the speed of what you can buy today, right? So we're upgrading to the 2nd generation that just came out this week. But what we're seeing in our data is that the performance on the new, with the new Xeon processor, 2nd generation of Intel Scalable Platinum, with the new persistent memory, is that performance is about 60% faster versus, on average. You know, some queries, and remember, we ship 1 billion things a year, right? So there's hundreds of millions of transactions, tens of millions each day, right? So our query time on our database can be on a 3 to 5 terabyte instance. It's going to vary. You know, it's obviously seconds, but across the board, the average time that it decreased is by 59%. So if you're still on E7 V3 or E4, that's another reason to move. Yes?
When you're talking about a 60% improvement compared to the previous generation.
Compared to E7 V3, yeah.
Is that with or
So the Spectre meltdown, what we saw is there's about a 3 to 5% hit in putting that new code for HANA. So the other thing to realize also, if you go to the SAP HANA benchmark page, anything that's new, it has to adhere to the new standard, which includes the patches for Spectre meltdown.
That's 60%.
Yeah, that 60% is with the patch, yes. So like I said, another way to look at it is we went from a 3 terabyte system to a 9 terabyte system. The investment, I'm going to be honest, was flat, but we got 30% more capacity. So if you don't remember anything, just remember you're getting more capacity at lower cost, right? And that's because the price point per terabyte is going down if you use persistent memory versus DRAM.
You can't run your OS on the persistent memory. Okay?
That is correct. That may be the case in the future. I cannot disclose that. But we shall see.
And how far in the future can you not disclose?
I cannot disclose that. Well, you can obviously think that the next logical step is we're going to have bigger size, persistent memory modules, right? Okay, and so at our day of launch, anybody heard of the company Evonik? Anybody know? So they're a large German specialized chemical manufacturer. So at Sapphire, we're going to have a whole bunch of these one-pagers that talk about success stories. Another company that does appliances in Europe, Geberit, did it a POC. There's several that are happening in the Google Cloud, and several with other OEM partners, whether it be HPE, Lenovo, Cisco, Dell. There's still work that's going on that we're trying to get ready for Sapphire. But this one highlights in their scenario, their data load on startup. It improved, or the restart time improved from 27 minutes to a minute and a half. And this is, if I remember, about a 2 terabyte instance. And they saw that the system response time was about 60% faster. And once again, they came to the same deduction as Intel IT, that it cost about 30% less. And the reason why it costs less is because persistent memory is less expensive and they needed less systems, right? And the operating cost went down because you have less systems, electricity price goes down, right? And if you want to learn more, go to intel.com/SAP. And SAP also has a website dedicated to persistent memory. And that's on sap.com persistent-memory. So I'm excited to say we finally have the product out the door. We missed Hossel's deadline of shipping in Q4, but it is now currently shipping. You can buy systems from Lenovo. You can go to the GCP Cloud. Next week I'm actually speaking at Google Next, and there'll be some announcements around persistent memory there too. So something to look forward to. Any questions? You guys ask questions as I go. Yes. Well, thanks for coming today. I don't have any chameleons to throw out to you. So.